Today's lesson has two objectives. The first objective is to build on what we previously learned with systems of linear equations, or a system of linear equations, and apply it to an actual fact pattern. And then we want to differentiate or distinguish between linear and nonlinear equations. So taking a look at example 1. Creative Crafts gives scrapbooking lessons where they charge $15 per hour plus a $10 supply charge, while Scrapbooks is just $20 per hour. Now, I want to be able to graph this and compare the two plans on a graph. Okay? Now, to be able to do that, I want to be able to write an equation that models each of the two plans. Well, the first thing is, what is our unknown? Our unknown is hours. Okay? So what I want to do is, I have Creative Craft here, and I'll have Scrapbooks on the other side. I want to write an equation that models what Creative Crafts charges. Well, what do they charge? They charge $15 per hour plus a supply charge, and that equals Y. And what does Y represent? My total cost. Scrapbooks is very simple. They just charge the $20 per hour. Now, to graph these, as opposed to trying to just simply use the slope and y-intercept, let's just set up a very simple table of values. The minimum number of hours I could start with is 0. And for Creative Craft, if X is 0, then my cost is 10. If I use it for 1 hour, 25, 2 hours, 40, and 3 hours, 55. For Scrapbooks, if I don't use it at all, I don't get charged anything. 1 hour, 20, 2 hours, 40, and 3 hours, 60. So now I want to graph this relationship. Well, we said X was our hours, so that's our x-axis. And Y is our cost. So for the X, I'm really only going from 0 to 3, so let's give ourselves a little space here. Graph that. And for the Y's, I'm going to go from 0 to 60, so I'm going to count by 5s. So this will be 5, 15, 25, 35, 45, 55, and 65. Okay? So now I'm going to graph each relationship. Well, what am I going to graph? I'm just going to graph the 4 points. 0, 10, 1, 25, 2, 40, 3, 55. So there's Creative Crafts. And now I'm going to do the same for Scrapbooks. 0, 0, 1, 20, 2, 40, 3, 60. Now, you can draw a number of conclusions based upon this graph. The first is, at $40 or 2 hours, both plans cost the same. If I'm using it for less than 2 hours, then the plan in red, Scrapbooks, is going to cost less because the line is below the other line. If I'm going to go above 2 hours, then the plan in blue, Creative Crafts, is going to cost more because it's below the red line. And that's the type of judgments, or not judgments, but conclusions I can reach, and they're much easily determined when you look at the graph. Okay? Now, second example. You go to the store, you buy muffins, you buy quarts of milk. One person buys one combination, gets charged 18. The other person buys another combination, gets charged $7.50. So 8 and 2 is 18. 3 and 1 is $7.50. Well, I have two unknowns. The first one is the cost of a muffin. And then the second one is the cost of milk. So what's my first equation? 8x plus 2y is 18. And my second equation, 3x plus y equals 750. Now, the problem here is I can't solve any equation individually because they each have two unknowns. So what I want to use is the strategy we used before the break, which is substitution. So what would be helpful is to get the second equation into y equals form. Now, why is that going to be helpful to us? Well, let's take a look as I extend the page. There we go. All right. If you look at the first equation, 8x plus 2y equals 18, I can't solve this by itself because I have an x and a y. So it would be very helpful if I knew what either x was or y was. Well, we just figured that out. Right here, we figured out that y is negative 3x plus 750. So now I can replace the y with negative 3x plus 750. Now I have only one variable. I'm solving a linear equation by first using the distributive property, combining my like terms. So what I have found out is that the muffins cost $1.50. Now I want to figure out what the milk costs. Well, the simplest thing is to take either of these two equations, this one or this one, and put x in. The second one is a little simpler. The numbers are smaller. So when I put in $1.50 for x, I find out that y is equal to $3, and that's the cost for the milk. Okay? All right, now the second part is we want to distinguish between linear and nonlinear functions. Okay, and we've done a little of this before. And a linear function, it graphs as a line and has a constant rate of return. Or constant rate of change. Sorry. Nonlinear is the flip side. It doesn't graph as a line. And doesn't have a constant rate of change. Okay? Now, we're going to do a process similar to what we previously did to determine by a table of values whether this is linear or not. If you might remember, we looked at our rate of change. Plus 2 here, minus 15 there. Is that a constant rate of change? Yes. So it's linear. If you might remember, we figured out that the equation of this line, change in y over change in x, and then I want to figure out my y-intercept, which is when x is 0, going backwards, y is 65. Now I look at the second one. Well, the x's are changing by plus 3, but the y's do not change by a constant amount. So this is nonlinear. And in fact, if you look at it, you can write this equation as y is equal to x squared. Well, the equation itself also tells you it's nonlinear because when the exponent is greater than 1 over any of the two variables, that's not a line anymore. Now, a square is the length of s inches. The formula for area of a square is s squared. So if it has a length of 1, it's 1, 2 is 4, 3 is 9, 16 and 25. Well, you should see this is nonlinear. As I go up by 1, I'm going up by 3, then 5, then 7, then 9. Okay. Now, the last scenario, let's look at the graphs. Very straightforward. Is it a line or not? This is clearly not a line. It's a curve-shaped figure called a parabola. The second one's a little tricky because there are two line segments, but it is not a line. It's nonlinear because it doesn't make one intact line. The third one, again, pretty straightforward, nonlinear. You have this little curve area there, okay? And then the fourth one is obviously linear.